Tech in 5.
In an age where everything is online, how safe are you really? Today, we're diving into our first secure coding practice, input validation. At its core, input validation is about checking the data our applications receive, whether from users, files, or other sources, ensuring it's safe and as expected. Our primary objective with input validation is to block data that's incorrect, harmful, or unexpected, preventing potential security issues. Input validation is our first line of defense for blocking major attacks like SQL injection, where attackers manipulate databases through insecure inputs, XSS, which involves injecting harmful scripts, command injection, executing unauthorized commands, and buffer overflow, overloading our systems. Each of these can be mitigated by rigorously validating inputs. In defining acceptable input, we set straightforward rules: match the data type, like numbers for phone fields, stick to the right format, limit numerical values to specific ranges, restrict text to a certain length, and decide which special characters are allowed. These steps ensure only valid data enters our system. In managing inputs, we use whitelisting and blacklisting. Whitelisting allows only safe inputs, like specific email formats or password rules. Blacklisting, on the other hand, blocks known dangers, like SQL keywords or script tags in inputs. While useful, it's less reliable because it's hard to predict and block every possible harmful input. Let's focus on 3 pillars of input validation: type, syntax, and semantics. Type checks ensure inputs match their expected types. Syntax checks verify syntax compliance. Semantic checks ensure inputs like dates are logical, such as past dates for birth years. These steps guarantee inputs are valid, properly structured, and make sense within the application's context. In refining input validation, we start with regular expressions to specify what's acceptable, ensuring inputs match defined patterns. We implement length checks to cap input sizes, guarding against overflow attacks. It's important to balance client-side validation for user experience with server-side validation for security, never relying solely on the client side. When errors occur, we provide generic error messages that inform without exposing vulnerabilities. Additionally, we apply encoding and escaping techniques to every input, further preventing injection attacks. Lastly, we leverage framework-specific features like those in Java or .NET, which offer robust validation tools out of the box. Here, we delve into practical examples of input validation techniques. On the left, we're using Java to validate an email address with regular expressions. On the right, our focus shifts to C#, where we validate a numeric input, specifically an age field. These examples underscore the versatility and necessity of input validation in maintaining the integrity and security of our applications. In handling user input, all input must be thoroughly validated. When input validation is successful, the input can be safely processed. However, if validation fails, the input should be rejected to prevent any potentially harmful data from being processed. Then, the incident must be logged, capturing essential details for security monitoring. Users should be presented with a generic error message. These practices should be taken to maintain security and user experience. Input validation isn't a one-time process. It should be continuously reviewed and updated as the application evolves and new threats emerge. As we wrap up, remember that input validation is more than just a line of code. It's the foundation of secure application design. By diligently validating every piece of input, we not only protect our systems from common vulnerabilities, but also build a trust layer with our users. Let's commit to making input validation an integral part of our security culture, ensuring our applications remain robust fortresses in the face of evolving cyber threats.
Stay tuned for more videos on Tech in 5.